Good morning, students. So today we are discussing the next topic, that is the nuclei. Okay. So here we have different branches in physics. In that, one of the branch called as, that is nuclear physics. So we have a branch named as nuclear physics. The nuclear physics is the branch of physics which deals with, that is nuclear physics. So this nuclear physics is a branch of physics which deals with the study of constituents and properties of nucleus. Constituents and properties of nucleus. Okay. So nuclear physics is the branch of physics which deals with the constituents and properties of the nucleus. That is called as the nuclear physics. Here we are using the term here, students, that is the constituents of the nucleus. So what are the constituents of the nucleus? Already in the previous topic we have discussed. The constituents of the nucleus are, that is electrons, protons, and neutrons. So these are the what these are called as what constituents of the atom. So electrons, protons, and the neutrons are the constituents of the atom anta helbodu illi. Okay, so these are the constituents of the atoms. So what are the constituents of the nucleus here? So here we are dealing with the topic that is nuclei. Hagadre nuclei is a plural word. So nucleus. So nucleus is constituents. The constituents of the nucleus are, that is protons and neutrons. The protons and the neutrons, these together it is called as nucleons. ಇದೆರಡನ್ನ ಸೇರಿ ನ್ಯೂಕ್ಲಿಯಾನ್ಸ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಪ್ರೋಟಾನ್ಸ್ ಮತ್ತೆ ನ್ಯೂಟ್ರಾನ್ಸ್ ಅನ್ನ ನ್ಯೂಕ್ಲಿಯಾನ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. So ಇದೇ ನ್ಯೂಕ್ಲಿಯಾನ್ಸ್ ಇದೆ, this is called as this is nucleus. It is nothing but the constituents of the nucleus. These are the constituents of the nucleus. So constituents of the atoms anta helidre 3 particles barutte: protons, electrons, neutrons. So nucleus anta helidre there are only 2 constituents, that is the protons and the neutrons. The protons and the neutrons together it is called as what? Nucleons. Is it clear? So this is the introduction part of the nuclei or the nucleus. So here ಏನೆಲ್ಲ ಹೇಳಿದ್ವಿ, that is what are the constituents of the atom. Already atom ಅಂತ ಅಂದ್ರೆ previous topic ಅಲ್ಲಿ discuss ಮಾಡಿದೀವಿ. The constituents of the atoms are that 3 are there: protons, neutrons, and the electrons. So ಅದ್ರಲ್ಲಿ proton ಮತ್ತೆ neutrons ಅನ್ನ neutrions, that is nucleons ಅಂತ ಹೇಳ್ತಾರೆ. It is called as what? Nucleons. So this nucleons is constituents of what? It is the constituents of the nucleus. ಇದೆಲ್ಲಿರುತ್ತೆ? ಇದೆರಡು nucleus ಇಲ್ಲಿರುತ್ತೆ. Okay. Here we have some of the basic terms again related to the chapter. So before that, here you see, in every atom the positive charge and the mass are densely concentrated at the center of the atom, forming its nucleus. So ಯಾವುದೇ ಒಂದು atom ಅನ್ನ ನೀವು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, atom ಅಲ್ಲಿ ಸೆಂಟರ್ ಪಾರ್ಟ್ ಅಲ್ಲಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅಂಡ್ ದ densely concentrated mass will be there. So ಇಲ್ಲಿ positive charge which is concentrated at the center, this part is called as what? This part is called as nucleus. ಈ ಪಾರ್ಟಿಗೆ ನ್ಯೂಕ್ಲಿಯಸ್ ಅಂತ ಹೇಳ್ತಾರೆ. Okay, that is more than 99.9% mass of the atom is concentrated in the nucleus. So whole mass in nucleus ಇರುತ್ತೆ, that atom ಇರುತ್ತೆ, though 99% of the mass is concentrated at the center, that is nothing but the nucleus. Yes, what is nucleus? Hope so it is clear to you. Maybe little you might have studied in the chemistry also. Okay, so here we have one more term, students, that is repeatedly we are using this, that is atomic mass unit. So ಇಲ್ಲಿ nucleus atom chapters ಎಲ್ಲ ಕಲಿಬೇಕಾದ್ರೆ usually mass ಅನ್ನ ನಾವು ಎದರಿಂದ measure ಮಾಡ್ತೀವಿ? We express mass in terms of kg, grams, pounds, ಇದ್ರಲ್ಲೆಲ್ಲ ಹೇಳ್ತೀವಿ. But here whatever the nucleus and the atom mass is there, it is very small. ಇದೆಲ್ಲ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ kg, grams ಗಿಂತನೂ ತುಂಬಾ ಕಡಿಮೆ ಇರುತ್ತೆ. So for that reason we have the other unit for the measurement of mass in case of the nucleus and the new atom, that is called as the atomic mass unit. So atomic mass unit anna AMU anta ಹೇಳ್ತಾರೆ. So what is atomic mass unit? The unit to express atomic masses is called as what? Atomic mass unit. So illen unit ಇದೆ which is helping you to express the atomic mass. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? ಸೊ ಈಗ ಮಾಸ್ ಅನ್ನು ಯಾವ ರೀತಿ ಕೆಜಿ ಅಲ್ಲೆಲ್ಲ ಹೇಳ್ತೀರಾ, ಕೆಜಿ, ಗ್ರಾಮ್ಸ್, ಪೌಂಡ್ಸ್. ಎಸ್, so similarly atomic mass anna whatever the measurement is there, that is called as what? Atomic mass unit, that is AMU. Here the atomic mass unit is defined as, it is the 1/12th mass of the carbon 12 atom. So here whatever the atomic mass unit is there, this atomic mass unit is what? It is the 1/12th of the mass of the carbon atom. ಸೊ ಇಲ್ಲಿ ನಾವು AMU ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಏನಿದು AMU? ಇಟ್ ಇಸ್ ದಿ ಯೂನಿಟ್ ಟು ಎಕ್ಸ್ಪ್ರೆಸ್ ದ ಅಟೋಮಿಕ್ ಮಾಸಸ್ ಒಂದು. ಮತ್ತೆ ಇದು ಎಷ್ಟು ನೀವು ಡಿಫೈನ್ ಮಾಡ್ತೀರಾ ಅಂತ ಅಂದ್ರೆ, ಇಟ್ ಇಸ್ ದಿ 1/12th. ಸೊ 1/12th ಮಾಸ್ ಆಫ್ ದ ಕಾರ್ಬನ್ 12 atom. ಸೊ ಇದ್ರ ಬಗ್ಗೆ ನೀವು ಮೇ ಬಿ ಕೆಮಿಸ್ಟ್ರಿಯಲ್ಲಿ ಡೀಟೇಲ್ ಆಗಿ ಕಲ್ತಿರ್ಬೋದು. So here in physics, we don't require much detailed knowledge here. Just you remember the unit, because namak bari unit aste bekagate. Unit enide AMU. So what is AMU? It is nothing but atomic mass unit. Okay. So here we have some other terms in this chapter. That is nothing but the first one, the atomic number. The first one is atomic number. It is denoted by Z. So what is atomic number here, students? Atomic number is nothing but what? It is the total number of protons. It is the total number of protons in the nucleus. The total number of protons in the nucleus, or the total number of electrons in the nucleus, is called as what? Atomic number. Because number of protons is equal to number of electrons. ಹಾಗಾಗಿ ನಾವು ಯಾವ್ದು ಕೂಡ ಇಲ್ಲಿ ನಾವು ಡಿಫೈನ್ ಮಾಡ್ಲಿಕ್ಕೆ ಯೂಸ್ ಮಾಡಬಹುದು. The total number of protons in the nucleus is called as what? Atomic number. Or you can also say that the total number of electrons in the nucleus is called as what? That is atomic number, that is denoted by Z. Okay. So what is mass number C? So atomic number is over. What is mass number? Let us discuss. That is mass number. So mass number is denoted by the letter capital A. Here the mass number is nothing but what? The total number of nucleons. The total number of nucleons is called as what? That is mass. Yes. So mass number is what? That is the total number of, yes, protons and the neutrons together. It is called as what? That is the mass number denoted by A. So atomic number, mass number. Yes. Any doubt is there in the all these definitions? So we have defined what is the nucleus, what is nucleons, what are the constituents of the atom, then atomic number, mass number. Okay. Yes. So next one you see, that is neutron number. So now we understood that number of protons is equal to number of electrons irutte. ಹಾಗಾದ್ರೆ ಎಷ್ಟು neutrons ಇದೆ? Because the atom consists of protons, neutrons and the electrons. So the atom consists of protons, neutrons and the electrons. ಮೂರು ಇರುತ್ತೆ. ಸೊ ಇಲೆಕ್ಟ್ರಾನ್ ಮತ್ತೆ ಪ್ರೋಟಾನ್ ನಮ್ಗೆ ಎದ್ರಿಂದ ಗೊತ್ತಾಯ್ತು ಈಗ? ಬೈ ಅಟೋಮಿಕ್ ನಂಬರ್ ವಿ ಅಂಡರ್ಸ್ಟುಡ್ how many protons will be there, how many electrons will be there, and the proton and neutron together, it is called as the mass number. ಹಾಗಾದ್ರೆ to calculate only the number of neutrons, getting my point here, students? So So that Z is representing the number of protons and it is also number of electrons. Here A is what? Protons plus neutrons. So if you want to understand only the neutrons, so can we do it as A minus Z, which is giving you the number of neutrons, which is giving you the number of neutrons. Yes, see. So A minus Z is giving you the number of neutrons. Understood? So A is, remember, A is called as mass number, which is both proton and neutron. Z is either electron or proton, ಎರಡು same ಇರುತ್ತೆ because atom is electrically neutral in nature. Okay. So A minus Z is called as what? That is number of neutrons. It is nothing but number of neutrons. Okay. So now, how to represent the nucleus? Let us see. So the representation of the nucleus is given by, if I consider X as any one element, X as any one element, so A is telling you the atomic number, that is the mass number. Z is atomic number. So this is the representation of any atom. So for example, if you see, if I am writing here, that is helium 2, 4, it means that, so X is nothing but helium atom here, and Z is what? Z is the atomic number. Sorry, it is the atomic number. That is equal to 2. A is equal to how much here it is? That is A is equal to 4, and A is mass number. This is mass number, and this is the atomic number. It is proton or electron. This is proton plus neutron. So if I want only neutrons, it is A minus Z. That is 4 minus 2 is equal to 2. So 2 is the number of neutrons. So we have 2 electrons, 2 neutrons, 2 protons. Yes, is it clear? So this is a representation of any of the atom anta ನೀವು ಇಲ್ಲಿ ಹೇಳ್ಬೋದು students. So now after this we have some of the definitions. Let us see what are those definitions. The chapter is maximum we have the definition. Derivation part ಏನಿದೆ that is deleted. That is the radioactivity part is deleted. So we have only basic definitions only in this chapter. Yes, so here you can see the composition of the nucleus. The composition of the nucleus can be described by using the terms atomic number, which is number of protons is equal to number of electrons, and the mass number is nothing but it is the number of protons and the neutrons inside the atomic number of the element. So that is Z plus N. So here one formula we will see, then we will go for the next terms. The radius of, so the radius of the nucleus having the mass number A, it is given by, the radius is given by, that is R is equal to, the radius of any of the nucleus is equal to, it is R naught A raised to 1 by 3. R naught A raised to 1 by 3, where A is called as the atomic number, where A is called as the, sorry, A is the mass number. Yes, A is mass number. What is R naught? R naught is here the radius constant. R naught is the radius constant, and its value is 1.3 into 10 to the power of minus 15 meter. So R naught is the radius constant and its value is 1.3 into 10 to minus 15 meter. A is the mass number. So R is the radius of the nucleus. So ಯಾವ್ದಾದ್ರು ಒಂದು ನ್ಯೂಕ್ಲಿಯಸ್ ಇದ್ರೆ ಅದ್ರ ರೇಡಿಯಸ್ ಅನ್ನ ನೀವು ಈ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು. That is R is equal to R naught into A raised to 1 by 3. R naught is radius constant. Its value is 1.3 into 10 to minus 15 meter. A is the atomic, sorry, mass number. Okay. So remember the formula to calculate the radius of the nucleus. Okay, so here we have some of the definitions, students, which is again important for 1 mark. So the first definition is, that is the isotope. So see, what do you mean by the isotopes? Isotopes have similar chemical properties but different physical properties. Those are called as the isotopes, or you can also define it in one more way. Okay, so ಇಲ್ಲಿ ಮತ್ತೊಂದು definition ಬರಿತಾ ಇದ್ದೀನಿ. The isotopes are nothing but these are the nuclei having same atomic number. So same atomic number will be there, but different mass number, those nuclei are called as what? Isotopes anta heltare. So what are isotopes here? The isotopes are those which are having the same atomic number but different mass number is called as what? That is the isotopes. So what are the example for the isotopes here, students? The example for the isotopes are this H11, H12 and H13. So hydrogen illi three examples. And the first one is called as hydrogen, second one is deuterium, third one is tritium. Okay, so these are the isotopes. Idರಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ ನೋಡಿ, Z same ಇದೆ, 111 ನೀವು ನೋಡಬಹುದು ಇಲ್ಲಿ suffix. Yes, so A value is different. Here it is 1, here it is 2, here it is 3. So the A value is different but the Z value is same. Those are called as what? Isotopes. Yes, you can see the isotopes. What do you mean by the isotopes? What do you mean by isobars? See, these are having same mass number but different atomic number. So ಮೇಲ್ಗಡೆ ಏನಿತ್ತು isotopes, reverse will be the isobars. So isobars are having the same mass number. Isobars are having the same mass number but different atomic number. Those are called as what? Isobars. Those are called as isobars. Here the example is H13 and helium 2 3. You'll note both new 3 3. That is A value is same but the Z value is different. These are called as what? Isobars. Yes. Isotopes we have discussed. Isobars we are discussing. The next one is isotones, students. So see, isotones andre en nodi. The nucleides having the same number of neutrons are called as what? Isotones. The nuclei having same neutron number but different atomic number. So these are having the same neutron number but different atomic number as called as what? That is isotones. Hagadre isotones again examples nodana. So the example for isotones are, that is H13 and helium 2 4. Yes, so ಇಲ್ಲಿ ಏನಂತ ಹೇಳಿದೀವಿ definition ಅಲ್ಲಿ for the isotones? These are having the same neutrons. So same neutrons. What is the formula to calculate neutrons? It is A minus Z. So A is how much? 3 minus 1 is how much? It is 2. Similarly for the helium. So for the helium it is 4 minus 2. So 4 minus 2 is it is 2. Yes, so ನಿಮ್ಗೆ ಏನಾಗ್ತಾ ಇದೆ ಇಲ್ಲಿ same number of neutrons ಇದೆ, that is 2 2. These are called as what? Isotones. But what will be same? Atomic number will be same, but atomic number will be same. Yes. Last one. These are the the last one. Here it is. We will study one more point, that is called as the isomer. So in chemistry you might have studied about the isomerism. So isomers andre, these are the nuclei having same atomic number. Isomers, these are having same atomic number. Atomic number will be same andre, Z is same atomic number and same mass number. So mass number is also same, atomic number is also same, but different internal structure. Internal structure will be there. That is called as what? Isomers. That is called as isomers. Yes. So see all the definitions. If any confusion is there in any of the definition, please ask. So first one is isotopes. Here it is written this side. The next one is isobars. This one with pink color. And the next one is isotones, here with the green color. And the last one is isomers. Yes. See, if you have any doubt, you can ask. Otherwise, just make a point of this. We will go for the next one. Yes. Completed. Next point. Okay. So next one, that is the next point we are discussing is nuclear mass. Okay. So how to express the nuclear mass here? So the nuclear mass, it is the sum of the masses of the protons and the neutrons present in the nucleus is called as what? Nuclear mass. So here the nuclear mass is given by, it is the mass of proton plus mass of neutron. Mass of neutron is called as what? That is the masses. It is called as the nuclear mass. So this nuclear mass is given by the formula, that is Mn. The nuclear mass Mn is equal to, it is Zmp plus A minus Z into Mn. Z into Mp. So Z is the atomic number, Mp is the mass of the proton, plus A minus Z is mass of the neutron into, this is number of neutron into mass of the neutron. This is giving you the mass of the nucleus. Because ಈಗಷ್ಟೇ ಹೇಳಿದ್ವಿ ನ್ಯೂಕ್ಲಿಯಸ್ ಕಾನ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ಸ್ ಏನ್ ಬರುತ್ತೆ, ಪ್ರೋಟಾನ್ಸ್ ಮತ್ತೆ ನ್ಯೂಟ್ರಾನ್ಸ್ ಬರುತ್ತೆ. ಅದು ಎರಡು ಮಾಸ್ ಅನ್ನ ಆಡ್ ಮಾಡಿದ್ರೆ we will get the nuclear mass. Correct. So how to write mathematically? That is the mass of the proton is given by Z into Mp plus A minus Z into Mn. Okay. So here Mp is the, if you don't know, please write down the terms. Here Z is representing the number of protons. The Z is the number of protons. A minus Z is the number of neutrons. It is A minus Z is the number of neutrons. Here Mp is the rest mass of the proton. It is the rest mass of the proton. And Mn is the rest mass of the neutron. It is the rest mass of the neutron. Okay. Where A is called as, it is the mass number. A is mass number. So if you don't remember, please write down the terms. So A is the mass number, Mn is the mass of the neutron, Mp mass of the proton, A minus Z number of neutrons, Z is the number of protons. Okay. Next is nuclear density. Yes. So next is the nuclear density. The nuclear density is given by the next formula. So three formulas we have come across. Radius I2, mass of the nucleus I2. The next one is nuclear density. Nuclear density. Yes, this nuclear density is given by, it is the ratio of nuclear mass upon nuclear volume. So usually density is defined as mass by volume. So here we are defining for the nucleus. Therefore, nuclear density is the ratio of nuclear mass upon nuclear volume is called as what? Nuclear density. Yes. So copy down. And radius, already I told you in the previous slide. The radius of the nucleus is given by R naught into A raised to 1 by 3. Where R naught value also I told you, it is 1.3 into 10 to the power of minus 15 meter. Yes, this is regarding the nucleus. Three formulas we have: the nuclear density, the nuclear mass, and the radius of the nucleus. Okay. So all the three formulas take down. So it will help us to see some 2 marks numerical, simple one. Yes. Okay, next to see some of the points regarding the nucleus again. Yes. The order of the nuclear charge. These are the constant numbers you can remember here. So for the MCQs, you can make a note of this. So see, order of the nuclear charge or the, yes. So in the previous lesson, we have discussed the nuclear charge is given by, it is plus Z into E. So nucleus anta L bandru kuda adra charge anna ZE anta tagoltivi. Q1 is equal to athwa Q is equal to ZE anta baratte. Okay, so the charge is of the order of 10 to the power of minus 19 coulomb. So illen charge ide, idrada order estirutte, it is 10 to the power of minus 19 coulomb. And the mass of the nucleus is of the order of 10 to the power of minus 27 kg. So charge, this is mass of the nucleus is of the order of 10 raised to minus 27 kg, and the charge value is of the order of 10 raised to minus 19 coulomb, and the charge of the nucleus is always taken as plus Ze. The next one, the nuclear size. So charge aitu, mass aitu, the nuclear size is of the order of 10 to the power of minus 15 meter. So size is of the order of 10 raised to minus 15 meter. Okay, so here you remember one more point, that is volume of the nucleus. Whatever the volume of the nucleus is there, it is always directly proportional to mass number. Volume of the nucleus is always directly proportional to what? It is mass number. Okay, so volume of the nucleus, we can take it as what? 4 pi r cube upon 3, 4 by 3 pi r cube is directly proportional to A. So idanne navenanta baritivi, r cube is equal to r naught into A, or r cube is proportional to A, or r is proportional to A raised to 1 by 3. Next, we remove the proportionality sign and we take a constant r naught A raised to 1 by 3. R is equal to ide barate, ide ರೀತಿಯಾಗ formula derive ಆಗುತ್ತೆ. So that is from the concept, volume of the nucleus is directly proportional to mass number. Yes, the next point regarding the nucleus, the next point is the density of the nucleus is of the order of, the density of the nucleus is of the order of 10 to the power of minus, 10 to the power of minus 17 kg per meter cube. Yes, so these are the some of the points regarding the nucleus here, students. So charge of the nucleus anna Ze in the denote ಮಾಡ್ತಾರೆ. Then the charge value is always taken as 10 to minus 19 coulomb, and the mass is taken at 10 to minus 27 kg. The size of the nucleus is taken as 10 to minus 15 meter, and the volume of the nucleus is always proportional to what? Mass number, that is 4 by 3 r cube. 4 by 3 pi r cube is proportional to A. So that is radius is equal to r naught A raised to 1 by 3. And the density is given by 10 to the power of 17 kg per meter cube. Okay, these are the some of the points regarding the nucleus. Weightage, actually they have deleted what all main means, more weightage concepts it is deleted, that is radioactivity and all. So hardly you can expect here 2 to 3 marks, that's it. Okay, so max will be 3 marks, rare case 4 marks we can expect, or maximum marks will be 3 only on this chapter, because idr mele in radioactivity anta ella ittu, that is radioactivity law, alli formula barutte, derivation barutte, that part is deleted for this updated syllabus. So for that reason here it is not there. Okay, Yes. Getilla. Okay. Yes. Okay, the last point regarding this nucleus. So here AMU we have defined, that is atomic mass unit. Here 1 U is equal to. Now we are seeing one point, that is show that one atomic mass unit is equal to 1.66 into 10 to the power of minus 27 kg. So we have to prove that 1 AMU is equal to 1.66 into 10 to minus 27 kg. So to prove this, what we are writing, that is 1 U is equal to, so we know that one atomic mass unit is equal to what? That is mass of one carbon 12 atom divided by, it is C12 atom, right? So it is divided by 12. So mass of the carbon 12 atom is given by, it is 1.99264 into 10 to the power of minus 26. This divided by 12. So if I divide this one, we will get it as 1.66 into 10 to the power of minus 27 kg. They will not ask you, just for your understanding, you just know, you should know the 1 AMU value is how much? It is 1.66 into 10 to the power of minus 27 kg. Okay. So that is given by 1 unit is equal to mass of 1 carbon 12 atom upon 12. So that is 1.9926 into 10 raised to minus 26 upon 12. So if you simplify, 1.66 into 10 raised to minus 27 kg anta baratte. Okay, just you should know this value, that's it. This is in terms of kg. Now we are proving one more point. That is one AMU is equal to, or 1 unit is equal to, 1 atomic mass unit is equal to, so 1 U is equal to 931 mega electron volt. So you will see this point many times. So let us see how to prove this one, but you remember, okay. So here according to Einstein's relation, nimage gottirbodu, Einstein's equation is, that is E is equal to mc square, right? So in this E is equal to mc square, here mass is equal to, just now we have proved, that is 1 U is equal to how much it is? 1.66 into 10 to the power of minus 27 kg. C is the velocity of light here, students. So velocity of light is 3 into 10 to the power of 8 meter per second. So formula enide, according to Einstein, it is E is equal to mc square. So therefore E is equal to, m value is 1.66 into 10 raised to minus 27 into C value is 3 into 10 to the power of 8. So here C square is there. We need to square this term. Okay. So if you simplify this, no need to remember I had this one, just for your understanding. That is 14.92 into 10 to the power of minus 11 joules anta baratte. So ಈ joules ಅಲ್ಲಿ ಬಂದಿದೆ, ನಮಗೆ ಈಗ ಆನ್ಸರ್ ಬೇಕಾಗಿರೋದು electron volt ಅಲ್ಲಿ. ಹಾಗಾದ್ರೆ ಏನ್ ಮಾಡ್ತೀರಾ? Divided by, ಹೌದಾ? That is 14.92 into 10 to the power of minus 11 upon 1.6 into 10 raised to minus 19. So if we divide this, we will get it as how much? That is 931.5 mega electron volt. Or we can also roughly now idanna 932 anta kuda bariತೀವಿ. We write it as 932 also. Yes, copy down this. So previously what we proved, 1 U is equal to 1.66 into 10 raised to minus 27 kg anta prove ಮಾಡಿದ್ವಿ. Here we are proving, that is 1 U is equal to 931 or 932 mega electron volt. How we are doing this one? By using Einstein's mass energy relation, that is E is equal to mc square. So m is 1.66 into 10 raised to minus 27 kg. C is 3 into 10 raised to 8 meter per second. So use this one. Answer joules ಅಲ್ಲಿ ಬರುತ್ತೆ. Convert ಮಾಡಬೇಕಾದ್ರೆ electron volt ಅಲ್ಲಿ divide ಮಾಡಿ. So your answer is 1 U is equal to, ಅಥವಾ 1 AMU is equal to 931.5 ಅಥವಾ ಕೆಲವೊಬ್ರು ರೌಂಡ್ ಮಾಡಿ ಕೆಲವೊಂದು ಬುಕ್ ಅಲ್ಲಿ 932 ಮೆಗಾ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಅಂತ ಕೂಡ ಇರುತ್ತೆ. ಎಸ್, okay students, so chapter is full theory, no derivation, nothing is there, just theory only it is there. So copy down this one. We will meet in the next class with the nuclear force concept. Okay, yes, copy down. So sometimes they will ask, prove 1 U is equal to 931 or 932 mega electron volt. If any doubt is there, please ask students. Otherwise, we will meet in the next class with the next point. Any doubt is there? Yes. Okay. Thank you.